Good evening everybody. Today let me invite you all for the sessions of basics of signals, which is my third lecturing hour. This topic is coming under video syllabus for 4th semester ECE students under module 1. This can also be studied by any other branch students, EEE, IT, TC, whoever they are having signals and systems, or anybody who is other than engineering students, whoever are interested in signal processing, digital signal processing as areas of their domain, maybe company peoples, you all can take up all these videos. You can see lecturing sessions of mine. I have posted some 72 videos, right, based on this only. Just like this, you will see all this. Now, let me go to this is a very basics of signal systems actually. In my previous sessions, 2 sessions, I have talked on signals, definitions of signals. We defined what is signals and how it is useful in today's scenarios. And then different types of basic signals we taught. Ramp signals, impulse signals, step signals, and signum signals, rectangular, like that we all see in different types of signals. Now today let us see what are the basic operations we can do it on that signals, right? Basic operations like like additions, multiplications, subtractions of operations, integration, differentiations on these signals. Applications we will see, right? There are 2 types of basic operations done on, right, the signals. That is, basic operations done on dependent variable. Anyhow, we'll see now. That is one sessions. Let me say, in these sessions I am taking up this. Then basic operations done on independent variable. Right? There are some set of basic operations which we can done on dependent variable and independent variable same way. We'll see today in these sessions this basic operations done on dependent variable. Right? Now, let us say, for example, y of t is equal to a into x of t. Here t is independent variable. Whole x of t is there, no? That is, right, the signal, full signal is there, no? That is depending on a, amplitude a. That is as dependent variable. For example, here, let us say, one-dimensional signals can be defined using 2 variables. Let us say one-dimensional signals, that depends, y of t depends on x of t along with a. Right? Now let us see, dependent variable means what actually? Dependent variable here corresponds to amplitude or value of the signals. For example, this is a variable x of t depends on, right, corresponds to amplitude of the or value of the signals. Right? This x of t depends on this a. Right? That is called dependent variable. Independent variable is one which corresponds to, here t is there, no, that is t or n. In this case, this is continuous time signals we are taking. Therefore, y of t output depends on a into x of t, continuous x of t. Here t or, if it is continuous time signal, it is t. If it is discrete time signal, same is y of n is equal to a into x of n. Here n, right? This n is there, no, corresponds to t or n corresponds to the discrete, what is that? The independent variable. This changes independently. Depending on this changes. Right? Now let us see basic operations which we are doing it on dependent variable only. Full variable. For example, x of t with amplitude. Right? That way what are the operations we can do? We'll see. Later, the basic operations done on independent variable, that is inside. For example, x of at, inside. This is independent variable, inside its scaling factor is a. Now, we will see dependent variable. Full variable depending on this a. Right? What are the operations? We will see in these sessions. For example, basic operations carried on dependent variables are 1. Additions of 2 signals we will see. Next. Right? Same way, addition operations, then the multiplications operations, maybe scaling operations. 4 operations are there, 4, 5. Then multiplications operations, then differentiations operations, and then the integrations operations, like this integrations operation. Now let us see one by one. Right. First let me take off addition operations, additions of two signals. Right. Now see, for example, let x1t and x2t be two signals. Then additions of signal is being done by, right, adding two signals x1t plus x1t and putting it into y of t. Right. Now what will happen? The value of y of t here, y of t, depends on, is obtained by, in case of this addition operation, adding, simple additions, adding values of x1t and x2t, x1t and x2t. By adding these, you will get value of y of t. Here what you should see is, you should see the amplitude of this. Maybe here in this case amplitude is 1, here amplitude is 1. Right? Then you should add both. Right? For example, if you take an example, x1t is let us say 2 volt peak to peak. Right? x1t, let us say, right, this is x1t, right, maybe 2 volt peak to peak. Then x2t maybe 3 volt peak to peak, 3 volt peak to peak. Then when you add this 2 plus 3, 5 volt peak to peak, you will get. Right? That is how addition operations is being used to add two signals. This is a real time we are using this in a lab. Right? Real time signal processing is nothing but more than one only signals we are using. Now, similarly, for DTS, if it is continuous time signals, then this is. Similarly, for discrete time signals, instead of x of n, x of t, what you have to write is x of n, discrete steps. Therefore, let x of same way, let x1n, x2n be two discrete signals. Right? Then add two signals using the same expression. Instead of t, just y of n is equal to x1n with some amplitude. Here you want unity amplitude 1, x2n, then you will get value of y of n. For example, take one example. x1n is 1, 2, 3, 0, 1, 1, 2, 0, 1. See this? x1n versus n. 1, amplitude, 2, 0, 1. x2n, same way, x2n signals, discrete time signal is, x2n is, amplitude is 1, 3, 0, 1. Then what will happen? Then see, when you add these two, x1 plus x2n, you will get additions like this. 1 plus 1 is 2. Then here 2 plus 3 is 5 amplitude. Then 0 plus 0 is 0. Then 1 plus 1 is 2. Like this, we can use addition operations both in case of discrete time and continuous time to add sequences, right? And we are doing that. Now similarly, second case now. How to use scaling operation is the next operations, right? Amplitude scaling it is also called as, right? What is this? Basic operation is amplitude scaling. Let us say now, for example, what do you mean by amplitude scaling? Let x of t be time, continuous time domain signal x of t, right? Then y of t is obtained by multiplying the x of t with a scaling factor c. Now see, y of t is obtained by just multiply x of t whole signal, I told you, dependent variable, by a scaling factor c. Then what will happen? This equation is called amplitude scaled versions of x of t. Now see, where c is nothing but is called scaling factor. Right? That is, the value of y of t is obtained by multiplying the value of this x of t signals. Maybe x of t signal is there, no? X of t, multiply this with some 2. Then y of t you will get as 2 into x of t like that. Right? That's what C2 is the scaling factor. That is one operation. Right? In real time, you have to multiply signals 100 times, 1000 times with the scaling factor of 2 only. Right? That's why this is useful. The value of y of t is obtained by multiplying value of the signal x of t by c. Similarly for DTS, same. Y of n, in place of t, just substitute n, discrete step. Y of n is equal to, then amplitude scaled version of y of n is equal to c into x of n, where c is nothing but same scaling factor for all the value of n. For all the value of n. This is all the value of t. In this case, right? In this case, this is all the value of t, right? Here in this case, it is all the values of discrete steps, right? That's scaling factor. Next, multiplications operations. You know this is very, very useful, right? Multiplying of signals actually. Let x1t, x2t be two continuous time signals. Then y of t is obtained by, then output y of t signals, right, is obtained by multiplying both the signal x1t and x2t. Let's say when x1t is 2 volt peak to peak, x1t let us say is 2 volt peak to peak, 2 volt peak to peak, let's say this is, then one more is a 3 volt peak to peak, right, x2t. Then y of t is obtained by multiplying these two, 2 into 3, 6 volt peak to peak you will get, right, like that. Therefore, right, is called now y of t is equal to x1t into x2t multiplied through both signals. This is called as multiplications of two signals. Multiplication operations is done. Then the value of y of t is obtained by, this y of t is obtained by, y of t is obtained by, right, multiplying the amplitudes of x1t and amplitude of x2t. Amplitude of x1t, amplitude of x2t. Multiply, right, for all values of t, you will get value of y of t. That is multiplication operations on signals, on any signals, two signals. Similarly for DTS, continuous time signals, whatever you done, just here discrete time signals, you have to replace t by n, y of n, x of n into multiplications of y of n for all values of n. Now in discrete steps, that's all. In steps 1, 2, 3, like. Now, that's all. That is the differentiation, multiplications operations in continuous time signals and discrete time signals. Now, last differentiations operations and integration operations. Very, very important operations in signal processing. Actually, this you will study as full unit in unit number 2, LTA systems. Right, both this. Right now, right, time being, let us study this for a little now. Then x of t be continuous time signals. Right, x of t. Then differentiations of x of t with respect to t is given by, you know this, y of t is equal to derivative of x of t versus d of t. Right, this is what, right, this is differentiation operations on signal x of t. Right, y of t you will get by differentiating x of t with respect to t. Right, if you give signals x of t, right, take that, differentiate with respect to t, you will get y of t signals. Right, full signals you have to do. Dependent variable, this is full signal. Right. Next, lastly, integrations operation. Let us see this in right, LTA systems, module 2. Then x of t be continuous time signals, right? Then integrations of x of t, this x of t is there now, that with respect to t is done by y of t is equal to this formula. Tau is equal to minus infinity to t, x of tau, d tau. This also we'll see in LTA systems, right? That this is all operations, right? Basic operations is being used on signals to do all these operations, right? Operations like additions, subtractions, multiplications, and scaling operations, amplitude scaling, then integrations and differentiations, right? Now let me quickly, right, repeat this. What is that? Signals, basic operations on, what are the basic operations on signals we are doing, right? Based on dependent variable and independent variable, there are different operations. 5 operations will be done here and other 3 operations will be done on independent variable. Today we will see now dependent variable operations. What are that? 5 operations. One is, right, addition operations, right? I told you dependent variables correspond, dependent variable and independent variable. Dependent variable corresponds to the full signal, amplitude or value of the signals. Full signal's value, amplitude or the signal value is called dependent variable, right? That dependent variable corresponds to this full value. Independent variable corresponds to only this variable inside t or n for continuous and discrete time signals, right? This is independent, this is dependent, right? Now, basic operations on dependent variable is addition operations. Then we know adding up two signals in case of continuous, in case of discrete, just n, that's all. Then take two signals and add the amplitudes, you will get the answers. Then scaling operations means amplitude scaling, right? Amplitude scaling. For example, x of t be signals, then multiply that signals with scaling factor c, like this. For example, c is 2, then 2 is the amplitude, right? Then similarly for DTS, just c into x of n. Then the multiplications operations will do the multiplications of two signals. Just multiply this amplitude 2 into 3, let's say 6, like that. Then similarly for DTS, just you write instead of y of t, y of n, x of n into y of n. Then in the end, differentiations operations which differentiate x of t own signals with respect to t. This will integrate this x of t with respect to t, right? X of tau with respect to tau. I hope I am clear, right? Next class we'll see the basic operations on independent variable. X of t inside is there, not the t. There are three operations we'll see in the next class, right? I hope I am clear. Now let me again end up with by saying this beautiful quote. What is that? A honest person has tough time in corrupt government. A honest person, right, has very tough time he faces in corrupt government. Same way, a corrupt person has tough time, is facing tough time in an honest government, right? That means the chances are 50-50. You need not have to worry, right? Only thing is you should know how to apply, right? So whatever the situations may be, what I want to say is, whatever the situations you may be, you follow honesty, which will take you longer and longer. Don't you want that? Follow this honesty. Thank you. Thank you very much.